Let's talk about alert fatigue. You know, that endless storm of noisy, frustrating alerts that pulls you out of deep work, or worse, deep sleep. Well, today, we're going to show you how to transform that chaos into a calm, clear, meaningful signal using service-level objectives, or SLOs, right inside Azure. Let's get into it.
So, let me ask you a question. Have you ever been woken up at 3 a.m. by some frantic page, only to find out it was just a temporary glitch that already fixed itself? An alert that screamed emergency, but in reality had zero impact on your actual users? Yeah, if your alerting system is constantly crying wolf, you are definitely not alone, and we're here to fix that.
So here's our game plan for this explainer. We'll start by digging into the real problem with most alerts. Then we'll bring in our hero, the SLO. We'll define a concrete target, walk you through building a much smarter alert, and then look at the incredible transformation from noise to signal. And don't you worry, we'll wrap it all up with a template you can use right away.
Okay, first up, let's talk about the fundamental flaw in most alerting setups. See, they're designed to tell us when our systems are having a tough time, but they completely forget to answer the most important question of all. Are our users even noticing?
This right here, this is the classic, isn't it? You get an alert that CPU usage spiked to 95%. You scramble out of bed, you log in, and poof, it's already back to normal. The system healed itself, no users were impacted. This isn't a signal, my friends, it's just noise. And it's the kind of noise that leads to serious burnout for your team.
So how do we break this cycle? Well, we shift our focus. Completely. Instead of obsessing over our server's health, we start focusing on the promise we make to our users. And that, right there, is where the service-level objective comes into play.
The magic words here are from the user's perspective. An SLO isn't about CPU percentage, it's a promise, it's a commitment. Something like 99.9% of user logins will be successful, or 99% of search queries will return in under 500 milliseconds. See, it's all about their happiness, not your hardware.
And to help us manage that promise, we get this incredibly powerful tool, the error budget. If your SLO is 99.9%, you're also saying that for 0.1% of the time, things might not be perfect. Now, this isn't a license to fail, it's a calculated budget you can spend on things like new feature rollouts, planned maintenance, or just absorbing unexpected issues, all without breaking that core promise to your users.
All right, enough theory. Let's make this real. We're going to define a clear, measurable target for a service that I bet a lot of you run, a simple API hosted in Azure.
You know, breaking it down like this is absolutely crucial. Our service is the API. The metrics that actually matter to the user, we call these the service level indicator, or SLI, are success rate and speed. And our promise, our SLO, is that 99.9% of requests will succeed and they'll do it in under 300 milliseconds. We'll measure that over a 30-day window. Simple, clear, and totally focused on the user.
Let's just lock in on that number for a second, 99.9%. Over a 30-day period, that actually gives us an error budget of about 43 minutes. That's it. That's our total allowable unhappiness time for our users. As long as we stay inside that budget, we are keeping our promise, no matter what our CPU charts might be screaming about.
Okay, so we've got our promise. Now, how in the world do we build an alert that only fires when that promise is in real danger? Let's jump into Azure Monitor, and I'll show you exactly how it's done.
You know, the process is surprisingly straightforward. We'll pick our metric, define what it means to burn our error budget way too fast, write a query to measure it, set the right threshold, and finally, make sure the alert goes to the right people at the right time.
First things first, we're going to ignore CPU and memory. We go straight to the source of truth, our application logs. In Azure Monitor, we can analyze logs from App Insights or other places to count the actual number of successful versus failed requests and measure their exact duration. This is the ground truth for what the user is experiencing.
Now, this right here, this is probably the most critical part of the whole thing. We do not want an alert for one single failed request. No way. We want an alert when we are burning through our 43-minute error budget at an alarming rate. For example, we could set an alert to fire if we are on track to burn our entire monthly budget in the next 24 hours. Now, that is a real problem that needs a human to wake up and intervene.
To measure that burn rate, we use Azure's super powerful Kusto Query Language, or KQL. Now, don't worry, you don't need to be a KQL wizard for this. The whole idea is just to write a simple query that looks at our request logs and counts two things: the total number of requests
and the number of good requests, the ones that return to success code and were faster than our 300 milliseconds target.
So, you've set all this up. Now what? What actually changes? Well, the impact it's profound. It's not just about getting fewer alerts, it's about fundamentally changing what your team focuses on day in and day out.
I mean, the difference is truly night and day. You go from this world of constant, non-actionable pages tied to abstract system metrics to a world where alerts are rare. But when an alert does fire, everybody on the team knows it's because our promise to the user is at risk. It's meaningful, it's actionable, and it protects your team's most valuable resources, their time and their focus.
And to help you put this all into practice, like right now, we've created a simple but really powerful template. You can use this as a blueprint for any service you want to monitor in a more meaningful way.
Look at how simple and powerful this is. Just walk through these questions for your own service. What are you measuring? What metric truly reflects if your user is happy? What's your promise to them? And, most importantly, what rate of your error budget burning is urgent enough to actually wake somebody up? Filling this out gives you a crystal clear, actionable plan for every important service you run.
So I'll leave you with this to think about. What is the single most critical promise your service makes to its users? Is it speed? Availability? Is it a successful transaction? And once you know what that promise is, how are you actually measuring it? Because the moment you start measuring what truly matters to them, that's when you can finally turn all that noise into a crystal clear signal.